Hello, I hope the first video lesson was okay with you and you were able to make some good notes. My goal is to look at two examples over here to see how we apply the concepts from the first video lesson. So I have a function over here called f of x equal to 1 over x minus 3. And when you look at it closely, it kind of mimics the function 1 over x, but not quite. So let's compare g of x and f of x. And I hope by now you kind of see what just happened. It looks like g of x was transformed by shifting to the right by 3 units. And once you see that, you literally take the graph of 1 over x, which is one of our basic block functions, and then use it to help you draw the new graph, which is 1 over x minus 3. So on the left side, I have the graph of 1 over x sketched with the horizontal and vertical asymptotes clearly showing in the graph over there. And then what you want to do now is you are shifting the entire graph, including the asymptotes, from where they are 3 units to the right. So pretty much the horizontal asymptote doesn't move, but the vertical asymptote has to move 3 places to the right. And then you can sketch the graph the way it's supposed to be. There's also a y-intercept that occurs by shifting, and you can clearly see from the function that f of 0 is equal to negative 1/3. So that is why we have a y-intercept at this location over here. So one of the ways that we can see transformation happen over here is we're able to see the sequence of transformation that happened. That way you're able to move your original graph to what the new function looks like. Now let's look at B. So B is not totally complete. We'll finish it up together. I have a function x minus 2 over x plus 3. And there's some basic things that I can find. I can find the domain. I can find the x-intercept. I can find the y-intercept. Also, by inspecting let me talk about the big idea. So the big idea has to do with the x-intercept. So if you look at the x-intercept, we set y equal to 0. And when you do that with this function that I have over here, you end up with p is equal to, p of x is equal to 0. So clearly, what this idea is telling us is that when you have a rational function and you're trying to find the x-intercept, all you have to do is set the numerator equal to 0, and that will help you find the x-intercept. Now, back to where we were. We need to try and sketch this. But I'm looking at this expression over here and I'm going, what's there? I'm saying that this is a transformation of 1 over x, but it's disguised. So the way we want to do this is to go through long division. So I already started a long division. Let's kind of finish it together. So you go through, you get 1 multiply. Oh, I did a boo-boo in the first place. So this is supposed to be a plus. So that when I move this together, when I subtract, I end up getting negative what? Negative 7. So let's fix this error over here. That's supposed to be negative 7. A bit interesting. So by looking at this new expression over here, we can clearly see where the 1 over x transformation came from. So let's look at the transformation that happened over here. We have, if we let g of x be 1 over x, then what happened was this was stretched 7. So I get 7 over what? 7 over x. and then it was reflected about the x-axis. I get negative 7. G of x, so I get negative 7 over x. And then this was shifted to the left by 5, so you get negative 7 g x plus 5, which is negative 7 x plus 5. And then it was raised up by, so negative 7 g of x plus 5 plus 1. That gave me 1 plus negative 7 x plus 5. So I see the sequence from 1 over x. So if you think about the graph of what 1 over x looks like, 1 over x looks like this, with a horizontal asymptote there and there, and the graph look like this. And so by inspection, let's see what happens. The big themes that happened over here was I need to reflect this function here. It's going to get stretched, so the next move was to do a stretch. So it got stretched vertically, so it gets a little bit thinner. And then it was inverted, so this is 1, 2, 3, 4. So this is 1. And then it was stretched, it was inverted, so I have my and so it was inverted, so this went this way. And that way. So this is 2. And then it was shifted to the left by 5. So when I draw the next one, I'm going 1, 2, 3, 4, 5. So I have and that. And again, now things starts getting interesting. So again, I'm just drawing that. Oh, my bad. Wrong way. Supposed to go the other way. So I have this and that. And this is number 3. That was that transformation. And my final answer is 1, 2, 3, 4, 5. And then it was raised up by 1, so I have. And so now we have the graph that looks like I was passing through a couple of things. So I was passing through 2, 0, and so let's say this is 1, 2. Then I have this point and this point that it has to pass through. I have that graph, and then I have this graph. So this is number 4. Okay. We can now also analyze what is the domain, what is the range. So from the graph, we can see that the range is what y belongs to So you're going to scan from negative infinity all the way to 1 union 1 to what? 1 to infinity. Okay, so we're using transformation of 1 over x to do most of your assignments for today. Okay, but make sure you understand these two examples.